Hello everyone, I am Hasibul Islam Showrock and welcome to my presentation. Today, my topic of the compare or contrast presentation. Newtonian gravity versus Einsteinian gravity. I will mostly compare or contrast the aspects of this topic will be force and 4D space-time. So I think from the science class of high school or middle school, you know what force is. And uh, even if you don't know what 4D spacetime or four-dimensional spacetime is, first let me explain it to you. So we have three dimensions of space, like height, width, and depth, or length, width, and height, or whatever you can say. So we have another type of dimension, but it is not in our control, and that is time. So when we combine these three, this becomes four-dimensional because it has four dimensions, three of length and three of space and one of time. So four-dimensional space-time because space and time both are correlated here. So let's start. For me, I prefer Einsteinian gravity to Newtonian gravity because Einsteinian gravity may be a bit complicated, but it is accurate. Newtonian gravity is accurate, but not all the time. In extreme cases, it fails to uh, predict the motion of planets and celestial objects. So I prefer Einsteinian gravity because of that. But Einsteinian gravity is a bit complicated than Newtonian gravity, but it is most it is more accurate than Newtonian gravity. Einsteinian gravity says gravity is a pseudo force because gravity doesn't act like a real force. Like, let me explain it a bit to you. So when you are in a bus or in a car, so the car is accelerating you forward, you feel a force backward. So when it is pushing you forward, you are you are experiencing a push backward. But in case of gravity, when you are falling down, you don't experience a force acting up. If there is no air atmosphere, so let's just assume there is no air tag or atmosphere for now. If there is no air, there is no atmosphere. When someone falls down, they do not feel any force upwards. So by that correlation, we get to know that gravity is actually not a force, but gravity is a pseudo force. Basically, it looks like a force, but it isn't actually one. And there is more to learn about this, but for this presentation, I will not go. Anyway, as I said before, Einsteinian gravity works in every cases, and Newtonian gravity works in most cases, but does not work in extreme. Like the orbit of Venus. The orbit of Venus is a bit complicated because as Venus orbits the Sun, the orbit of Venus also orbits the Sun. So it's a little bit complicated. It can be explained by Einsteinian gravity. The position and the momentum and the velocity of Venus can be extracted from Einsteinian gravity, but not from Newtonian gravity. Newtonian gravity fails in this case. So we can see that Einsteinian gravity may work in every case, but Newtonian gravity does not work in every case. Einsteinian gravity was first formulated by Sir Albert Einstein, and Newtonian gravity was first formulated by Sir Isaac Newton. Einsteinian gravity works with four-dimensional space-time, as I said before, but Newtonian gravity doesn't work with four-dimensional space-time, but it works with three-dimensional space. In Einsteinian gravity, time is relative, so something or some event that may happen in 3 seconds in my time can happen in 4 seconds in your time. Like in my perspective, I can see that something is happening in 3 seconds far, far away from me. But for you, that same event can happen in 4 seconds. So in Einsteinian gravity, time is relative. But in Newtonian gravity, time is absolute. For most of the day-to-day tasks and day-to-day activities, time is more or less absolute. But if we take the extreme cases, time is actually relative. So the main idea I want to you to learn from this compare contrast presentation, sometimes the simplest explanation, aka Newtonian gravity, is actually not the correct one, because if you want to be accurate in terms of like astronomy and other things, you need to consider these complex explanations as well if they actually predict what you want to know. So, when Einstein first proposed the general theory of relativity, basically Einsteinian gravity, he was having really big backlash from the physics community, which is actually kind of bad. So, for everyone who will be seeing this or hearing this, please, maybe in your life, when you see someone is giving a complex explanation, maybe sometimes try to understand what he or she is saying. So, the main idea what I want to convey from this presentation is sometimes the simplest explanation is not the correct one. Thanks, everyone.